Okay, welcome to week 5. Not too much with announcements. I want to just sort of keep rolling with what we were doing on Friday, but some fascinating things happened. So to clarify, just because it's been like a break, we had a pop quiz 1 that was a fake pop quiz. We were just talking about how being a reader and being a mather are different things. Pop quiz 2, renting or buying a house, I think worked okay. I just didn't give you enough time. But that was a learning experience for me, and I let you finish up at home. Pop quiz 3 that we did Friday with this road trip was disastrous in a different way. And so I need to do a little teaching and lecturing before I give you more class time to work on it. So if you weren't here Friday, then just hang on. Don't worry about the pop quiz part yet. And if you were here Friday, hopefully you have your paper. If not, I have lots more papers for people who weren't here or who lost theirs, as well as tape and scissors. So there was 2 parts of the activity. One part was to, a second time, and no one got to this, do the sort of turning a bar chart into a circle chart thing. So we did that at the beginning on Friday, and I think that went pretty well. I don't think any group was confused, and maybe it helped you understand percent of a little more when you labeled everything as percents at the end. So that was a good use of time. I think that was successful, and that's the one I've actually done once before. But the new thing was disastrous. And interestingly enough, because there was no 4J, and my kids were here, and I don't know why it was only my kids, because I know you have kids too, and they didn't have school, but I was the only one that brought them to class. And so I was asking my older boy how he did the problem when he was working with his group. And the answer was he just sort of lucked out. There was a 60 miles an hour and a 30 miles a gallon, and he thought I should smush together the 60 and the 30 to get 2, and then I have only small numbers. And it just happened that that was a good way to start things. It makes you think about gallons per hour, which isn't something we normally think about much, but it was okay. But there's a better way to do things. So I spent some time and made a new section. So if you have a printout, because I gave you one, or you printed it out, there's a new section in the Mad Science topic called Goeswith chains. And hopefully this will make sense. And if not, then oh well, I wasted a few hours over the weekend inventing this and typing it out nice. But I was talking with my kids in the car a lot as we were driving to and from gym and things, saying, so what was actually going on in your mind? What have you been taught before that helped you understand these? And I think I've kind of dissected what was going on enough that I can now teach this clearly. So that's where I want to start. And we can do homework questions after things, but I don't want to lose whatever momentum we might actually have after the weekend. So let me make this a little bigger. Okay, the order of operations and terms was where we ended, and that helps us use adding, subtracting, multiplying, and dividing. There is another operator that for some reason doesn't get taught in elementary or high school, but it should. And it looks like a fish, sort of. It's a stretched out Greek letter alpha, if you want to be technical. But if you just think it looks like a fish, good enough. And its official name is the proportional operator, but we're just going to call it Goeswith because that's what we're going to say anyway. And to use Goeswith, we do 3 things. We're going to list out a bunch of rates. We're going to write our goal so we know where to start. And we're going to then link the rates together in a chain. And we might have to unreduce or maybe even reduce some of the rates that fit the pieces together. And I'm just going to show you this in an example problem. So Goeswith is an operator that works with rates, whereas you normally add and subtract plain numbers, not fraction rates. So here we go. Did I make it too big? No, I didn't. Okay. So Lucy is driving from Eugene to Los Angeles. On average, She'll drive 7 hours a day, making it different than what we did Friday. 60 miles an hour. Gas costs $3 a gallon, and she has an old car. Even on the freeway, she only gets 20 miles a gallon. So we wonder, how much does she spend each day on gasoline? Everyone okay with what the question is? So I'm going to copy that image and go here. I'll be right back. I forgot to do this at the beginning. Okay. Oh, it's black. That's no good. Okay, I'll just have to write it. So what were these things? 7 hours a day, 60 miles an hour. Come on, what's wrong? There we go. I should copy that. Okay, now we can go. So 7. Okay, and now I'll pause and let you get your notes caught up. So we want to make a chain of things. And when we start writing the chain, we want to make sure we start in the right place. So the second step is to figure out what we're asking. So we're asking one day is so many dollars. And that just tells us we want to start our chain with one day. And when we get to dollars, we'll stop, because that's the answer we want. Then, when all that preparation is done on the page, we can actually start writing our chain. So one day goes with, and the only rate that has a day is the 7 hours a day. So there we go, 7 hours. So we've sort of checked off this one. Now I want 7 hours to go with something else. So what's the other rate that has hours?
60 miles an hour.
60 miles an hour. It doesn't have a 7 hour, but I can fix that. If I do times 7, top and bottom. So 7 hours goes with 420 miles. Now I want to move on from miles. So we've used that rate, we've used that rate. What's the next one to use?
Miles.
20 miles per 1 gallon, right? It's the only one left that has miles in it. So that has to be the next one to use. So I want 420 miles. What am I going to unreduce by? So 7 times 20 would just be 140. That's not big enough. 21. How did you get the 21? Yeah, 420 divided by 20, I need a factor of 21 in there. Right. So that's going to be 20 times 21 will be, again, 420 miles like we want, and 21 gallons. Need to move this up a bit. Okay. So 420 miles now goes with 21 gallons. And now we've used that rate. We're not at dollars yet. What do we do? Yeah, so this rate will get us from gallons to dollars. That's what we're wanting. So far, so good. We need 21 gallons, so we have to fix that with the times 21. So $63 goes with 21 gallons. And that's my answer. So all of these things are about one day. In one day you go 7 hours. In one day you drive 420 miles. In one day you use 21 gallons. In one day you spend $63. It's not quite an equal sign. Right? It's kind of comparing apples and oranges. It would be awkward to say that they're somehow equal to each other, but they go with each other. So that's why we call it the Goeswith operator. If you search on other websites, you'll find it's called the proportional operator, but I'm avoiding that for a reason about later on in class. Should we do another one?
Yeah.
Anyone need more time putting that in their notes? So there's all the steps written out in case you weren't here today, but it's prettier on the page with colors. Okay, Luke smokes half a pack of cigarettes each day. Each pack costs $6.15. How much does he spend per year on cigarettes? So we have, whoops, I need to get my colors consistent. Half pack per day. It's 15 per pack and 365 days a year. If you didn't realize that we needed to write 365 days a year in the beginning, you would realize it later on. We'd make our chain and we'd get stuck and need another rate to keep going. Okay, so that's a terrible word asking. Can you write that better? Will it let me? Come on, why can't I do it? Okay, what am I asking? How much will he spend per year on cigarettes? So I want 1 year is how much money? That's an important step. Otherwise, I'm not quite sure where to start my chain. So I'll start it with a year. A year goes with 365 days. I've used that proportion.
Yeah.
Okay, what do I do for my next step in the chain?
So you just decide how much I have packed.
Yeah, the only other one that uses days is that one. So that has to be the one I use next.
So you just divide 652 by 2.
So what is 365 divided by 2?
One like you're doing the harder one.
Oops.
Isn't there an easier way to do that?
There is if you have an intuition about it. And there is another way that doesn't help you build up the intuition called unit analysis that we'll get to later. So I'm trying to do something that's similar to the measurement unit conversion, but also lets you do more than one step. Okay, last step.
Multiply by 615,
Multiply.
180.
Yeah. And if your intuition is good, then you can just do the multiplying. But the advantage of this is it's sort of a fail-safe thing. If you're not sure if I should multiply or divide, by forcing the rates to match each other, it's telling you whether you should multiply or divide. So you don't have to worry about if your intuition is failing you or not. Let me go back to what we were doing with measurement units, which I also retyped to explain better. Okay, I'll come back to this, but let me take a step down over here. So when we did one-step measurement unit conversions, let's go over how that worked. When we were going from feet to inches, we could say that 1 foot is multiple inches, right? More than 1 inch in a foot. Just like 15 is lots of 3s, 5 3s, then a foot is a bunch of inches put together. So there was a rule that when you had going from a multiple measurement unit to its parts, you multiply. We called it bigger to smaller before, but I think multiple and multiply is easier to remember. And then you could say an inch is like a factor of a foot, just like 3 is a factor of 15. It's the small part that fits in nicely to the big thing. So when you're going from a factor measurement unit, like from inches to feet, then you divide. Because factors and division go together. So this worked for things that you could picture the pieces. You can picture pints going into a gallon. You could picture inches going into a foot. But this guideline about when to multiply and when to divide doesn't work quite as well when the rates are different kinds of things, like dollars and packs. So if you aren't sure, should I multiply or should I divide, then by doing this orange stuff, yes, it is extra writing. It does kind of slow you down. But it's telling you that you need to multiply and not divide here. You can be certain that everything matches, because 1 year does go with 365 days. 365 days does go with, whoops, I need to label it, 182.5 packs. And 182.5 packs does go with the $1,122.38. So it's a way to be fail-safe and on a test, on a midterm, not have to worry about, do I multiply here or do I divide here? Is it making people happy to see this compared to Friday or not? A new experiment.
Okay, so I can find it for like a couple dollars different.
That's fine. If you round it in the middle, it will be a little different.
Oh, so
Well,
you're
no, but I'm
rounding?
saying I did mine the whole different way, but you ended up with 11, 22, 38, and my way that I thought that if I divided, I got the price of a half pack for each day.
Mhm.
and then I timed it out by 365, it's like a,
Yeah, it'll be a little off because you rounded that price to dollars and cents.
yeah, because I got 1124, yeah, 20, but like,
Close.
what would it be traffic on the thing?
It would be okay on a test.
Oh, it would be, okay.
But we're not, Luke is not going to smoke exactly the same amount every day. So this is not a completely
All right.
accurate, realistic number.
I was just making sure, because I was just a little bit off, but I like that.
Unless he has some sort of automatic smoking machine that always does. But no. Okay, let's do one more.
Yeah.
So where were we? We were over. I thought this was interesting. Maybe it's not, but the average American car, when I searched online, costs $710 a month to own a car. So express this in cents per hour. If you own a car, but here you're in my class instead of there, then how much money are you spending just every hour because you own a car?
Do
Okay.
we know whether it's the month of February or December?
We're going to use 30. So if you went back to the web page, then it would say that let's use 1 month as 30 days. Because I wanted to avoid that argument. Okay, so what are we asking? What's the thing we know and what's the thing we're looking for? Yeah. Are we starting
Maybe
with
how
1
much
cent?
per year?
Are we starting with 1 cent or 1 hour for cents per hour?
Oh.
It's going to be one of those two things. Put that down now. Which is fixed? Do we know the cents or do we know the hour? We know the hour, yeah. So every hour, we're asking how many cents. Does that make sense? We're not saying in 1 cent how many hours go by. Okay, so we need some rate with an hour in it. What rate is that going to be? I'll ask you before I just write it. If we're starting with an hour, we want to move away from hours. How do we get towards months, starting with hours? Days, yeah. So 24 hours, 1 day. And in this case, I'm not multiplying, I'm dividing. Because I want 1 hour. And this again might look like I'm writing too much and being weird, but it's telling me when I multiply and when I divide, so I don't do the wrong one by accident. I need to divide by 24, not multiply by Okay, I'm still trying to get from days to months. So which rate do I want to use? I need a new one. It's the one that I put here so we don't argue about it. So a month is 30 days. When I do 30 divided by this, then I get to divide 720. So I'll divide by 720. I'm doing 1 divided by 30 divided by 24. Yep.
I don't know.
Where's the 720 coming from?
The 720 is, let me move this down a little. Oops.
Oh, okay. Because that equals 1.
Because I'm trying to make the denominator match what I already have.
Okay. I see what you're doing.
I'm really,
There'll be another way we do this called unit analysis later. So if this isn't working, that's fine. This is trying to help some people get a better intuition of unit analysis.
my brain's lost. So we would,
You're not
it would be 7. Ooh, I don't like that.
So we want 1 divided by all of that stuff. 0.0013. Why did that move? There is. But the easier way is just going to be a process you follow, not something that might help.
My calculator didn't get this thing. It should have-
And
Oh, okay, if I added it up.
this one is too awkward. I need a better way. Yeah, this is why people use unit analysis.
It's all done. I'm gonna be there. I like that one.
You like the other one?
Can you only pick easy ones on the test?
Yes, but we'll have a better way.
All right, sounds good. I feel like it wouldn't really care. What is it? What I'm trying to figure out. 1 hour equals.
So 98.6 cents.
I know.
Okay, so this one had too many decimals. That defeated everything.
I know.
It complicated things.
Yeah, the problem was we started with this tiny thing, the hour, that was smaller than the month by too much.
You won't make it that hard on the test.
No,
I don't know.
Okay, so yeah, ignore that one. That one was bad.
Sometimes I feel like I know what I'm doing.
Does this one work? Did this help compared to what we did on Friday? Or was this one equally bad? It just didn't look as bad.
Just didn't look as bad.
I didn't look as bad as the last one you did. That one I didn't.
That one
I know, I mean, that last one was a doozy.
I feel like I would never try to figure out how many cents
I
an
wouldn't use
hour.
that method.
I was like, I don't really care.
Okay, I will change that example problem before I do. So,
Yeah.
Was this one helpful to see? Or was it also just?
I mean, it was a lot easier to,
Yeah, I like those numbers.
yeah.
Yeah.
We need to go from something bigger to smaller.
Because I'm, like I said, I don't want to figure out, and I can figure out the cents.
I know.
Okay, well, I will leave this one up on the screen because this is the one that relates to what you just did here.
Oh.
And what happened on Friday, if you weren't here, was I was trying to put together this kind of thing and then the cute thing with the artwork. And this kind of thing, since I hadn't taught it at all, took all 20 minutes. And I thought, well, I'm giving everyone 20 minutes instead of 10. So this, and we just did a little thing that was very similar to this. Yeah, so I thought it would be great. But no, this thing, since I hadn't taught it, took too long. So, but this, if this part makes sense to one person in your group, then you can get this done. But don't run away when you're done. Okay. If you like doing this with just the measurement unit conversion way, where sometimes, whoops, that wasn't that. Sometimes you multiply and sometimes you divide, and you just have some intuition on when to multiply and when to divide, and that can work. But not everyone has a good intuition for that. So I can't just say, sometimes you multiply, sometimes you divide. I have to use a little more guidance. And that's what I was trying to do with this one. And then I confused you by doing too many problems. So there we go. Okay, so get back in the groups that you did quiz 3 with. I'm going to pause the recording. And so we're at percent of, and we got there by going to mad science and starting our percents. This is review from Wednesday, I believe, if I'm remembering right. We were wondering what's the percent of a number, like how much we spent on food on that road trip problem. Maybe you had $70 on food, you were having an expensive vacation, and every day you were spending 400. So 70 is what percent of 400? To do that, first we realized that the word of means multiply. And so that happens all the time. If you have 5 tickets and 5 copies of 25, you multiply. If you had a fraction, 3/7 of 350, you would multiply. So we did a few problems with that. And we saw that for percentages, the only thing that was different was that you had to do ripple up first. So let me go back to Wednesday. Come on. Is this ring the bell?
Yeah.
60% of 200, it would be 60% times 200. So it's fine. The only thing different was for 60, you had to ripple up, so you could stick it in your pocket. Then the kind that we just did before was, oops, yeah, those are the easy ones. Then, no, I'm gonna go back here because I lost. There we go. Then there was percent change, where you were trying to find the percent. That's like the one I just misspoke and said to you earlier with the what percent of your daily cost is food. So you're given 2 numbers, and you do division. The problem with percent change is that sometimes the dollar amount was provided for you. It was 15 cents off of that 75, not 15 cents of the new price, but 15 cents off. And other times, they gave you the new price, and to get the discount, then you would have to subtract it. Say 80 minus 60 were 20 cents off. So you had to find it either way. They gave it to you or you did some subtraction. And then you did the division just like we did in the pie chart. So that was this one. Where we said, no, that's the one where you start with a percent. We want that one. So 15 divided by 75 was 0.2, and then you rip off it at the end to get 20%. Or in the next example problem, 80 minus 60 was 20 cents. The part divided by the whole, change divided by original. Does that ring a bell from Wednesday? Yes. Yes. Okay. Sorry, it took me a little bit of flipping to find the right slides. Okay. So this was the summary thing. If it asks for a percent, does it show or hide the discount amount? If it asks for a number, then sometimes you had to add it back on. If you invest $100 and it goes up 5%, you have $5 more. But are they asking for that 5, or are they asking for the new total, 105? Because I didn't lose my original. So that was where we ended up. And so the next thing to do, which I will show you, and then we'll do it again on Wednesday, because a bunch of people left after the quiz, is the 1 plus trick. So if we had $100 and it went up by 12%, the nice thing about 100 as a number is the percent of the dollar amount. Right? 12 out of 100 is 12 out of 100. Right? So then if it asked us what's the new amount, we'd have to add the 12 back on. The 100 plus 12 is 112. So what if we didn't have to do 2 steps? So there's a trick, the 1 plus trick. When we multiply by a percent increase, we can first add 1 to the percentage, and it keeps it around. So instead of multiplying by 0.12, I'm going to put a 1 in front and multiply by 1.12. And that way, I have a times 1, which means nothing happens at 100. And I have a times 0.12, which means give me $12 more. And they work together. So if the problem is asking the new total, not just the change, then this will save you a step. Because it's really easy to put a 1 in front of a number. So let's do a few of those. Finally have a nice, simple thing that I don't do badly as an experiment. So we have a $5,000 loan. It has an 8% annual interest rate, so it's going to get bigger by 0.08. And instead of writing times 0.08, if I put a 1 in front, then I get 5,400. You can check on your calculator that the same thing happens. I'm going to move that 1 off the decimal point just a little bit. So the times 1 kept the 5,000 around. The times 0.08 said make me $400 bigger, 12% bigger. So we got it all in one step. Get it? Well, you don't, let's just do another one. So how much do you want to start with? What's our investment amount? 925. Okay, so we have 925 to start. Maybe we're saving money. Maybe something is appreciating in value because we're collecting fine art. Maybe there's something that's, whoops, to start, not start. Maybe we are just having something that gets more expensive. You know, the fancy microwave goes up in price because this new year it has more features. Okay, what % increase do we want? 18% more. Okay. So I'm going to take the 925 and I'm going to multiply it not by 0.18 because that would be just the change only, but a 1.08 and whatever that is, 925 times 1.1. Okay, better now? No. Should we do another one?
I get it. Yes. We're adding a one and then don't know why we're adding.
Because if we just did 925 times 0.18,
It would be right.
then
We would just get 7.
and we get the 166.50. Then we'd have to do another step. Oops, no, I'm trying to scroll down.
Oh, 166.
Okay, then we'd have to add back on the 925 to get to our answer. So the idea is adding the 1 saves us that step.
Okay.
We don't have to add the original back on
So
anymore.
we just.
It's saving a little time because adding, not only did I have to see the 166.50, which I didn't really care about, but then I had to add it. Whereas putting a 1 in front of a decimal point is so fast.
Okay.
Let's write it on the other one if that helps. So here, if we did 5,000 times 0.08, we'd get 400. So that's why we're. So if that helps you do homework, good. Otherwise, don't worry about it. We'll do more in 2 days.
Then I'll ask questions.
Monday's down, baby. Oh.
I don't know, I don't want.